All right, this is the second video for the lab, Series versus Parallel Circuits Lab 3. We've already investigated how voltage is distributed in a series circuit. Now we're going to look at the parallel circuit. So we want to go down to step 9 and create that circuit, which we've already done. You can see that right here. We'll turn on the switch and make it active. We'll go to step 10. It says measure the voltage across the battery and the light. So we'll do that. So the voltage across the battery, is 9 volts. You can see that right there. And then the voltage across the light bulb is also 9 volts. So we can record that information right there. Then number 11 says add a second light to the circuit in parallel. So we're going to add another light. And we're going to get these wires out of the way. So add a second light. Like that. So we're creating another path in our parallel circuit. And there we go. You can see the brightness of the bulbs hasn't changed. Number 12, or step 12, says measure the voltage across the battery and both lights. So again, we'll measure the voltage of the battery, and you can probably guess that it's going to be 9 volts. And now we'll measure the voltage across light bulb 1 and path 1, and it's 9 volts. And the voltage across bulb 2 and path 2 is also 9 volts. You can see that right there. So you can record that there for number 12. And then it says in step 13, add a third light to the parallel circuit. So we'll essentially do exactly the same thing as we did beforehand. Adding a third path with a third light. And should be activated now. Okay. And then step 14 says measure the voltage across the battery and all 3 lights, and this is where you want to record that information. So again, the voltage across the battery shouldn't change. It's going to be 9 volts. The voltage across the first light, can you predict what it's going to be? Yeah, it's 9 volts. The voltage across the second bulb, also 9 volts. And you should be able to predict now what the voltage across the third light bulb in the third path should be. And you should predict, yes, it's going to be 9 volts. So that's what you want to record for step 14 there. Question 15 says, what happens to the voltage across the lights as more of them are added? So you'll notice that the voltage of the battery stayed 9, and every time we added another light bulb, another path, the voltage stayed the same. The first bulb stayed at 9 volts when we added the second pathway, and when we added the third pathway, the voltage in the first and second bulb stayed at 9 as well, and we measured the voltage across the third bulb to be 9 volts. So the voltage doesn't change no matter how many pathways you're actually changing, or adding. Step 16, or question 16, when you measured the voltage across the battery and lights, what did you notice? Well, if you go back to our software, here's the voltage is 9, 9, 9, 9. So that means the voltage is the same everywhere in our parallel circuit. What does this teach you about how voltage is distributed or spread in a parallel circuit? Well, what you got to note is that the voltage coming out of the battery isn't divided between the paths like it is in a series circuit. In fact, the voltage coming out of the battery is the same as the voltage in each of our paths, assuming, of course, that the resistance of our loads and our light bulbs are exactly the same. So we don't divide the voltage up in a parallel circuit like we do in a series circuit. So that's a major difference between series circuits and parallel circuits.